Hello, my friends. You're welcome to my YouTube channel. We have a very interesting math problem. Let's go through the question together. We are asked to find the maximum value of x if x is equal to a squared b plus b squared c plus c squared a. But then we are given that a plus b plus c is equal to 6. And also we are informed that a, b, and c belong to the set of positive integers. How do we go about solving this question? The first thing we need to have at the back of our mind is, what are the sets of positive integers? It starts with 1, 2, 3, 4, 5, 6, and so on and so forth. So the least member of the set of positive integer is 1. So what it invariably means is that A, B, and C cannot take any number that is less than 1. With that at the back of our mind, let's go to the solution of the question. So we write solution. Let me divide my board into two. The first thing we're going to do is to make an assumption. Let's assume that we say, let A be greater than or equal to B, and let B be greater than or equal to C, then definitely C will be greater than or equal to 1. Why did I say definitively that C or A or B will be greater than or equal to 1? Because I've stated earlier that the set of positive integers, the least value we can get from the set of positive integer is 1. That is the reason why we have 1 here. With that at the back of our mind, let's try to be creative. I can isolate this part of my assumption. C is greater than or equal to 1. I can isolate it. It's permissible. It's permitted rather that I isolate it. This is the back of my mind. I want to go back to the given, which is A plus B plus C is equal to 6. So what I want to do now is that I want to make C the subject of the formula in this equation, the equation which we were given. So the way I'm going to do it is that I will say C is equal to 6 minus A minus B. I simply move these two variables to the other side of the equation and I got this. Now the next thing I'm going to do is to rewrite this inequality, but I'm going to rewrite it in terms of A and B. The only way I can successfully do that is if I substitute for C in this inequality with this 6 minus AB. So I'm going to replace, in place of C in this inequality, I'm going to write this. So let's do it together. This becomes 6 minus A minus B is greater than or equal to 1. 6 is a constant. 1 is also a constant. So I'm going to move 6 to the other side of the inequality. This becomes minus A minus B is greater than or equal to 1 minus 6. So at this point, if you look at these two terms, on the left-hand side of the inequality, they have minus in common. So I can factor out minus. This becomes minus into bracket A plus B, close the bracket, is greater than or equal to 1 minus 6 is 5, minus 5 rather, is minus 5. So I'll write minus 5 here. So having gotten to this point, I want to straighten out my inequality by eliminating the negative sign. And the only way I'm going to eliminate the negative sign in this inequality is by dividing both sides of the inequality with a minus sign. But have it at the back of your mind that whenever you divide an inequality by both sides of an inequality with a minus sign, the sign of the inequality which is going to flip. So let's do it. If I divide here by minus and I divide here by minus, this cancels this cancels this. So I'm left with A plus B. Instead of greater than or equal to 5, I'm going to write less than or equal to 5. This is very, very important to the solution to our problem. Look at this carefully. A plus B is less than or equal to 5. So what that means is that the maximum value the sum of A and B can take is 5. Everything is beneath it. And mind you, A and B are positive integers. So there is a restriction to the values that A and B can take. Having that at the back of our mind, let's still go back to the given, which is A plus B plus C is equal to 6. Combining the given and this and applying basic logic, you find out there are only three possible values of A that will satisfy the conditions that have been stipulated in this problem. The three possible values of A are A is equal to 4, A is equal to 3, or A is equal to 2. We cannot go beyond this. Check it logically. Because if you put A is equal to 4 here, it makes sense that B will be equal to 1 for our answer to be less than or equal to 5. If you put A is equal to 3, in the same argument, it makes a lot of sense. If you put A is equal to 2, it also makes a lot of sense. So we have already isolated the values of A. We are now left with the values of B. So if you look at it now, having three values of A has given us three possibilities, which we refer to as cases, three cases. So what we're going to do is that we're going to consider this as case 1, where A is equal to 4. Where A is equal to 3, we'll consider it as case 2. Where A is equal to 2, we'll consider it as case 3. We have A equal to 4, equal to 2, 3, and equal to 2. So we need the corresponding value of B and C in each of the cases. So if A is equal to 4, I know that A plus B plus C is equal to 6. Then if A takes 4, it means that A and B are left to share 2. Mind you, they are positive integers. So the only answer that can come up here to satisfy the fact that A, B, and C are positive integer, and to satisfy that A plus B plus C is equal to 6, must be that B will be equal to 1 and C will be equal to 1. This is what we're going to get in case 1. So for case 2, A is equal to 3. Then if A is equal to 3 and A plus B plus C is equal to 6, then C and B are left to share 3. If C and B are left to share 3 and C and B are positive integers, but mind you, from our assumption, B is always greater than or equal to C. So from that now we can say that the 3 that is remaining to be shared between A and B must be that B is equal to 2 so that C will take up 1. This is going to be the values of A, B, and C in case 2. We'll now go to case 3, where A is equal to 2. If A is equal to 2 and A plus B plus C is equal to 6, it means that B and C are left to share 4. If B and C are left to share 4, but mind you, from the assumption, the value of A, B, and C can be the same. So if A is equal to 2 and B and C can be are stipulated to share 4, then B must be equal to 2 and C must be equal to 2. So these are the three cases. Case 1, A is equal to 4, B is equal to 1, C is equal to 1. In case 2, A is equal to 3, B is equal to 2, and C is equal to 1. In case 3, the three variables have the same value, 2, 2, and 2. Having gotten to this point, we are almost through with the question. The question actually is that we should find the maximum value of x. We have an equation that links x with A, B, and C. So what we're going to do now is that we're going to find the values of x in each of these three cases. Then we'll compare the values of x. The one that is highest becomes our maximum value, and we must have solved the equation. So let's go ahead and do that. Let's bring out the relationship between the equation that relates x and ABC, ABC and A, B, and C. X is equal to A squared B plus B squared C plus C squared A. So we consider case 1 where A is equal to 4, B is equal to 1, and C is equal to 1. Let's substitute this value into this equation and see what we're going to get for x. X becomes 4 squared times 1 plus 1 squared times 1 plus 1 squared times 4. This is 16 plus 1 plus 16 plus 1 plus 4. Okay, because 4 raised to the power of 2 is 16. 16 times 1 is 4 raised to the power of 2 is 16. 16 times 1 is 16. Then 1 squared is 1 times this. This is 1. This times this is giving us 4. So we have 16 plus 1 is 17. 17 plus 4 is 21. So in case 1, x is equal to 21. This is the value of x in case 1. So we're through with case 1. Let's consider the value of x in case 2. In case 2, we'll say case 2 gives us that a is equal to 3, b is equal to 2, and c is equal to 1. Substituting into this equation, x becomes 3 squared times 2 plus 2 squared times 1 plus 1 squared times 3. 3 squared is 9. 9 times 2 is 18 plus 4 squared is 4. 4 times 1 is 4 plus 1 squared is 1. 1 times 3 is 3. This is equal to 25. So x is equal to 25. That is the value of x in case 2. So let's go to case 3. Let's see what the value of x in case 3 will be. Mind you, in case 3, the three variables are the same. So in case 3, a is equal to 2, b is equal to 2, and c is equal to 2. So x will become equal to 2 squared times 2 plus 2 squared times 2 plus 2 squared times 2. 2 squared is 4. 4 times 2 is 8. So x will become equal to 8 plus 8 plus 8. This is equal to 24. So x is equal to 24. So in case 1, the value of x is 21. In case 2, the value of x is 25. And in case 3, the value of x is 24. So from this, 21, 25, and 24, which is the biggest? 25 is the biggest. So the maximum value of x is equal to 25. So we conclude and say the maximum value of x is equal to 25. And we got 25 when A, B, and C are 3, 2, and 1, respectively. Thank you for watching. Please like the video if you find value in it. If you have any correction or any way you can solve this better, you can still drop it in the comment section. I will also urge you to please help us grow by subscribing to our channel. Thank you very much.